name is Jan Berglund. I'm the Director of Product and Solutions at Comba Telecom. Today I will talk about a radio vendor's view on disaggregation and what the architecture of OpenRAN actually means in practice. This is a traditional view of a RAN. Life was simple. This model has been used for a long time. It made sense in the past allocating variable parts of the standard to one location, the baseband unit. Complexity was done with software and accelerators. Radio function was a relatively fixed part that only changed when stepping waveform standards from UMTS to LTE to NR. With OpenRAN, the cutting point in the chain changes. Driven by technology progress, higher order MIMO requires a different fronthaul cutting point to fit the low-cost fiber fronthaul. With this fundamental shift comes two consequences. The radio that used to be a relatively fixed and simple function is now a quite complex function with a software component attached to it. There is also a significant redistribution of computational effort. Depending on the accounting model, an estimated 30–40% of the total computational effort is now residing in the radio. Part of this is what the market has been striving for. The CUDU can now be implemented on COTS hardware. It has become two separate units, CUDU software and CUDU hardware based on COTS. It also means that the ORU is now a software product, and by such, it is far more subject to changes in the standard. Having a more complex product with software embedded as an important part of it also makes it something that is subject to revision handling. Actually, prior to OpenRAN, I cannot ever remember myself referring to a RRU software release. More processing load is now embedded with the radio, with the consequence that additional cost comes to the radio in form of the additional components for this additional processing. But not only that, it also impacts power consumption. You can no longer compare traditional radio with the ORU radio one-to-one, as we have this additional processing built into the ORU radio. The same goes for the CUDU, but there the development has gone in the reverse direction. We will have reduced workload, we will have reduced application complexity. So where does this leave us? In theory, it's a zero-sum game, just different distribution. As a full E node G or E node B, the traditional RAN and the OpenRAN does the same work. There's no change in functionality by such. But the costs are redistributed. An OpenRAN radio will be more expensive as it requires more hardware to fulfill the additional function. It also requires more software, and a software maintenance is required over time. On the other hand, the CUDU costs have potentially been reduced as the application software complexity is reduced and COTS hardware can be used to do that smaller job compared to the traditional baseband unit. We saw on the previous slides some of the complexity that has been allocated to the ORU, but it doesn't stop there. OpenRAN is for many customers only viable if it can match or improve on the TCO. The MNO cannot reduce or remove services when switching solution. Some MNOs use a fair amount of radio access technologies concurrently, such as LTE, NR, GSM, LTEM, or NB-IoT. Running overlay networks many times do not reduce the TCO. Therefore, OpenRAN is challenged with delivering all the technologies that the legacy network delivered in the past. How do you practically address this? Let's look at GSM. Operators have stopped investing in GSM for some time now. Yet, GSM is embedded in our society and supplies critical services. For this reason, existing GSM stacks will need to be reused as much as possible to avoid having a reinvestment in something that is already working. For the radio, this means two different logical interfaces to the same radio. both the new OpenRAN 7-2 interface, but also a split 8 interface, where the traditional IQ samples gets into the virtual BTS for the future. Taking it one step further, look at this picture. We have a very crowded 5 technologies in one single radio. In reality, this is a request by one of our customers for our new triple band radio. So 3 bands, 5 modes in one single radio. Not only the radio product gets more complex, but the testing process and the IoT process also becomes much more difficult. Let's dive into next topic. It's been more than a decade now with network sharing. The lure is obvious. Reduce cost, reduce cost, reduce cost. But the complexity is also high. Not only from a technology point of view, but also from a business point of view. It's well known that many of these networks are loved and hated at the same time. The CTOs, they hate the network because it doesn't give them the control of it. And the CFO loves them because it gives this cost reduction. So let's step in and have a look at what it actually means for OpenRAN. After some head scratching a decade back on the challenges, we ended up with some working commercial models. They are based on that one entity is responsible for the site and the SLA it delivers. Typically, this is executed through a JV having an SLA agreement to multiple MNO participants, or by using a graphical split between the different MNO participants. How does this matter to OpenRAN then? The commercial model for how to operate a shared MORAN network gave some imprints on technology as well. As we can see on the left-hand side, all site specifics are owned and controlled by one master, whereas the other sharing party simply receives a service from this. Understudying the OpenRAN standardization is a quite more complex picture when MORAN capabilities are driven down to the radio level. There are those some question marks around this, as radio antennas and DU hardware are shared resources. Here you find a fictive dialogue between 2 operators. It's always been a struggle between control and practical execution capability. As there are shared components such as radios and antennas, one party cannot do changes without it having consequences for the other party. And this continues to be a challenge also in OpenRAN. So the question is, how far should we be distributing MORAN? This is about making OpenRAN fit the business. As a first step, OpenRAN should deliver a technical model that supports a current business demarcation. This will simplify the use of OpenRAN in MORAN use cases. The commercial models used have been there during the last 10 years and have been fine-tuned to work for the operators. This means a simpler first step for the OpenRAN industry and a simpler first step for the operators to embrace OpenRAN in MORAN applications. This is the last topic I want to address for today: interoperability testing as it stands today. In reality, we are not where we want to be. I think we all dreamt the dream about plug and play. We would take DUs and RUs and plug them together and they will all work fine. Reality is something else. It takes lots of time to do this IoT testing. It's partly down to the standard. The standard has many options, and with these options comes variations, and these variations is what causes a lot of time-consuming work. But it's not only that these options are there, it's also missing some pieces of it. So we find that with many of our DU partners, we need to have vendor-specific things that we implement on the RU to make the system work correctly. Which leads to the next topic around roadmaps. Each and every ecosystem partner, of course, have their own roadmap. And we need to align to these roadmaps, which is quite a lot of work. On top of it, Actually testing some of this is also time consuming, especially features like time in advance. It's not something you plug in and you get it working. It takes a lot of fine tuning to get the maximum performance out of the system. So all in all, doing IoT for commercial operations takes time and effort. And we do find ourselves making software vendor specific modifications to our software. Thank you for attending today, and thank you for letting us sharing our insights around OpenRAN from an RAU vendor's perspective. Thank you.